Hello people. We're just going to do a quick review of right angle trigonometry for right angle triangles. I've heard a teacher a few refer to right angle triangles as rats, and that's kind of a funny way to say it because rats sounds funny. And anyway, right angle trigonometry, right angle triangles. That's basically what we're going to review here. Okay, so do you remember SOHCAHTOA? Do you remember hearing that? Your teacher may have said it differently. They might have had a different way of remembering it, but basically it was just a way of memorizing. What does sine mean? That's the S. What does cosine mean in terms of the ratios? And what does tangent mean? So if I go let's see, let's just look at the part. If you remember, sine is equal to the opposite over the hypotenuse. So let's look at this triangle right here. Pretend you're standing right at this symbol right here. I forget the name of that symbol. It might be called a sigma. I forget. So let's pretend you're standing there. I'm going to get a pen to write with. And opposite from here, you have to memorize. What does opposite mean? Well, opposite is like a cross. You just go across, and here it is. Here's the opposite. Okay? And then the hypotenuse is always the longest side. This side right here, it's always across from the 90-degree angle. And that's called the hypotenuse right there. Okay? So sine means opposite over hypotenuse. Is that cool? All right. Let's take out this one. This is cosine. So pretend you're standing right over here, once again, and let's think about cosine. Well, cosine is adjacent right here over the hypotenuse. Okay? Cosine is adjacent over hypotenuse. And let's clear the ink. And let's see, the last one's tangent on SOHCAHTOA, and tangent means opposite over adjacent. So once again, if you're standing right here, if you're standing right there, opposite is right there, and adjacent is right there. Okay? So that's something you have to memorize in order to do right angle trigonometries. You have to memorize how to write this all out. Okay, so it's a good idea to practice this, and by practicing, all I mean is if I said cosine and you're standing right here at theta, if you're standing there, if I said cosine, remember cosine for this guy when you were standing down here was this side over this side, okay? But when you're standing here, it's not those two sides. The only thing that stays the same all the time is the hypotenuse. This always stays the same. But as far as adjacent or opposite, those depend on where you're standing. So if you're standing right here, here you are, there's your arms out. Adjacent now is right here. Okay, and opposite's over here. All right. So if we had numbers, let's say we had a 3 there, a 5 there, and a 4 over here. If they told us the length of all the sides, if they said what is the ratio, what is the tangent ratio for theta? So if you're right here, if you're standing right there, what is tangent ratio? So you'd write it out like this: tangent of theta is, and I think that's theta. It might actually be called sigma, and I can't remember the names, so hopefully you're not getting distracted by my lack of Greek knowledge. I have geek knowledge, but not Greek knowledge. No, anyway, so if tangent theta is 3, which is opposite, see, opposite over adjacent, so 3 over 5. That would be the tangent ratio, okay? If they asked for the sine of theta from right here, if they asked for sine, you'd write it like this: sine theta is equal to 3, which is opposite, over 5, which is hypotenuse. Okay, and this number always stays the same. And sorry, I had someone just talking to me there. Let's see, I got to make sure I'm actually not recording right now. Yes, 503, 504, it is all working. Okay, so hopefully you're comfortable with that. I've got some pretty good worksheets just to make sure you are comfortable with this basic stuff here. This is something that you would have been shown in grade 10, so I'm kind of skimming over it fairly quickly here. Just want to make sure that you get that back though, because it's something you may have forgotten. That often happens. We understand. It's not something you're using every day, right? Okay. So sometimes you are going to get a situation where you're asked to change a degree, so let's say 36 degrees, and you're asked to turn it into a decimal. In this case, using tangent. So the way it would be written is tangent of 36. Well, I'm not expecting you to memorize that, of course not. What you do is you take your calculator, and I'm going to show you the graphing calculator, turn it on. First thing you have to do, this is so important if you're just kind of half paying attention to this video, remember this part to begin with, okay? Very important. Make sure your calculator is in degree mode. Well, to do that on this calculator, just hit mode, and you go down and you look and you say, oh, it's in radians, it's not in degree mode. So you go down and across and hit enter. If you do not do that, your answers will not work out properly. So please make sure it's in degree mode. On other calculators, like a regular calculator, it'll just often say a D at the top or a DEG at the top, okay, just to make sure it's in degree mode. From here, it's super easy to answer this question. It's like free marks on a test. If they say tangent of 36, just go tan 36. Hit enter, and it will tell you the decimal right there, 0.72. Here, let's just make sure we got it right. There it is. Here it's just rounded off to 3 decimal places, so 0.727. Okay, make sure the calculator's in degree mode. Now, some calculators, you can't type it in like this. You actually type 36 first of all, and then you hit tangent. The fancier, newer calculators that show you all the stuff on the screen, you can type it in like I just did, tan 36. Okay? And I didn't have to put the brackets on the end there, but you can, and you'll get that answer. Okay? So that's how you answer that kind of a question. Well, what happens if they say, change a decimal, so this is going backwards now, change a decimal back to a degree. Okay, this is something very important to remember. First of all, whenever you're changing a degree into a decimal, whenever you're changing a decimal into a degree, or you're finding an angle, in other words, you're always going to push second function on your calculator. I'll show you what I mean. Okay, you start off by just saying, okay, we're going to go backwards here. We're going to type in, this calculator, I'm going to have to show you this. Sorry. See how it's written right here? Tangent, and then there's a little -1. To get that little -1 or inverse tan is how some people call it, you just type it in like this. You're going to have to push second function. Almost every calculator you'll have to do that, okay? Then you hit tan, and then you type in the decimal that you want changed back into a degree, 0.727. If everything works well, we should get an answer really close to 36 degrees. And there it is, okay? So you get about 36 degrees. You will always use one of the inverse buttons to go from a decimal to a degree. Okay? And here we just rounded it off to the nearest degree. Okay? I got a little hung up there for a second because I wasn't sure how to explain this. On a regular or an older fashioned type calculator, I think you would type in the 0.727 first of all, then you would hit second function, and then you would hit tangent. But this calculator, it doesn't work that way. I'm just saying for the older style calculators, okay? So those are 2 really easy marks on a test. You just have to punch them in your calculator. It will spit out the answer that you're looking for. Okay, so let's go try and solve a question here. It says 2 sides are known and 1 angle must be found. All right, let me get my pen here. Let me go get my pen. There we go. Get a pink pen, or let's go with pink. It's a little bit thick, so we'll see if it works. Two sides are known and an angle must be found. Okay, this is the power of trigonometry. They want you to find theta right here. And again, I might be saying it wrong. It might be sigma. I forget. Okay, but we're supposed to find this symbol right here. So what you do is you look at your situation. Across from this, you see a 25. Okay, so opposite this, you see a 25. Adjacent to this, you see a 15. There's nothing given in the hypotenuse. So it's like choosing a proper weapon. You're like, okay, do I choose cosine? That would be 15 over some unknown. You can't have two things that you don't know. We don't know the angle. We don't know the side. That's no good. How about sine? Well, you go across, so opposite, and opposite over hypotenuse. Two things we don't know. No good. So the best thing to choose here is, that's right, tangent. Okay, so you write tan, then the symbol, just to show what symbol you're talking about, that you're not talking about this symbol. And then you say, okay, 25 is opposite, that is opposite. Adjacent is 15. On your calculator, let's pull out the calculator here. I think we should move it out of the way. How do you do this on your calculator? Well, remember, we are trying to find an angle. We're trying to find an angle. Whenever you find an angle, let's go back. Whenever you're trying to find an angle, you always use one of the inverse buttons. Okay? So, what you're going to do is you're going to go second function, or inverse if that's what your calculator says. We've chosen tangent. 25 divided by 15. 25 divided by 15. Hit enter, and we've got it. There's our degree. 59 degrees. Okay? 50. I'm using the mouse to write right now, so it's not super clear. 59 degrees. We've just found it. Just that quick. That is this right in there. You know, if they asked us to solve this triangle here, if they said solve the whole thing, we know this is 59 degrees now. We could do that if we really wanted to. We could say, hey, every triangle adds up to 180. All three angles of any triangle add up to 180. So I can figure out this angle. Just go 180 minus 90. That's 90. 90 minus 59. Here, I can show you what I'm doing. 180 minus 90, and then subtract 59. Then that would give us this angle right here. We'd know that angle. Well, what's 180 minus 90 is 90. What's 90 minus 59? That's right, 30. What am I doing? 31 would be our answer there. 31 degrees. Okay? So this is 31 degrees. And then from there you could say, hey, I can solve this. I'm just going to say, you could use almost any one you want. Sine, cosine, tangent. Which one do you like? Well, tangent's not going to help us, but you could use sine or cosine. Let's just say you wanted to use sine. So you'd say, okay, sine of, it doesn't matter which one you use, 31 degrees is equal to 15 over, let's call this x. Opposite over hypotenuse. And then you would solve it from there. Okay? I'm gonna go to the next page to show you what to do when you have an x on the bottom or an x on the top. We're gonna actually do this question. I don't know, should I actually finish this question? I suppose we could just quickly finish it. Sine 31 is really like it's like over 1. You can do that with any number, right? And then just use, I guess, in the past we've talked about the Zorro method. So you start at the part you don't know. You go across, diagonal, and across. You multiply the two that are diagonal from each other, and you divide by sine 31. So let's do that. You go 15, divided by sine 31. And you get an answer of 29. So x is 29. X is 29. Does that make sense? Is 29 longer than the other two sides? Because it better be. Hypotenuse is always the longest side. So certainly that does look like a good answer. Okay, but you know, this was a little bit beyond what we were supposed to do here. Because it said at the top, when two sides are known, an angle must be found. Well, we found that angle, and I should have stopped and went to the next question. But hey, we just looked at this. That's okay. You got a sneak peek of the next questions here. All right. An angle and a side are known. Boy, you guys already know how to do this now. I already kind of just shown you. An angle and a side are known, and another side must be found. Find side C. By the way, side C, where is side C? Is it this, or this? Well, side C is opposite or across from angle C. Well, here's angle C right here. That means side C is right there. Find side C? Okay, cool. Let's do it. Look at what we have in front of us. Look what we have. We have 59 degrees here. We have a 25 here. And we want to find this. Well, look really closely at it. Pretend you're standing on the 59 degrees. We're looking at opposite. We have a 25. And then we want to go to the hypotenuse. Okay? We don't want to use adjacent because there's nothing here. We don't know how long this side is. So use the information that we know. So opposite and hypotenuse. That is sine. Okay? Sine is opposite over hypotenuse. Right in the 59 degrees. Okay? Then go, okay, 25 over C. And then from there, just do what we just did in the last question. Sine 59 is, you can put that over 1. Use the Zorro method. So start at the part you don't know, go across, diagonal, then across again. Multiply the first two numbers you meet, so that's 1 times 25 is just 25. And then divide by sine 59. Let's do it. 25 divided by sine 59. That rhymes. 29 degrees. Whoops, no, it's not 29 degrees. It's 29. I don't know. They never told us. It could be 29 centimeters, meters, I don't know. And I just realized when I got this answer that this question is actually the same as this one. Can you believe it? I just did it twice. You probably were telling me out there in computer land, but I didn't hear you because it's a one-way communication. That's the only downfall of this YouTube stuff is I talk and I don't hear you. I apologize. That's the next invention. I'll get rich when I do that. I'll hear students yelling, "What are you doing, you fool?" No, anyway. Okay, I will continue on. It says find side B using side C and 59 degrees. Okay, so we're going to find little b right here because big B is over here. Angle B. Little b is across or opposite from there. And it says to use this and to use side C, which is what we just found. Okay, so 59 degrees. Adjacent to us is B and the hypotenuse. So adjacent and hypotenuse. Adjacent and hypotenuse is, you guessed it, cosine. Cosine of 59 degrees is equal to B over 29. All right, so let's see if we can figure this out. Once again, just write the 1 underneath. Use the old Zorro method. Okay, start at the part you don't know. Draw a line across, then diagonal, and across. Multiply the first two numbers you meet, then divide by the last number. Okay, so cosine 59, that rhymes once again, times 29, cosine 59 times 29 equals that. Now you could divide by 1 if you want, but it's not going to change anything, okay? Whoa. You know what? Something went wrong there. Oh, I know what happened. Look at that. I typed it in wrong. It should be cosine 59. The problem is I forgot the bracket. The bracket is important here because up here it did the cosine of 59 times 29, which is not what we were looking for. We were looking for cos 59 and then end the bracket, then times that by the number 29. Okay, then divide by 1. Okay, 14.9. We could round it off if we wanted. We could say 15. But either way, we just figured out that this side here, this side right here is about 15 whatever. It could be 15 centimeters. And look at that. Before, the triangle from before verifies this. Okay, we know we did it. We got it. Is that the last question? It is. You're looking at a white screen here because there's no more questions. So hopefully you get a little idea of trigonometry again. Trig is something that I really enjoy because once you catch on to it, it's actually pretty easy. Hopefully you too will find this something to smile about in the near future. Cheers.